Hi, fifth graders! Welcome back to our channel. Today, we're going to be working on classifying plane figures. So, there are two types of figures, well, one type. We have to classify polygons, okay? The thing to remember about polygons is that they are a closed plane figure that is flat and they have to have straight lines. So, for instance, if I look at this figure, it is closed, meaning that there is no, like if I was like a little person in this, I couldn't get out. It's closed, okay? It is a two-dimensional flat figure on a plane, but it doesn't have straight lines. It has curved lines. So that is not a polygon, okay? If I look at something like this, it does have straight lines, no curved lines, and it is a flat figure on a 2D plane. But if you look at here, that is what?
Open.
Okay, so that is not a polygon either, okay? If I look at this, it has straight lines. It has a closed figure, and it is on a flat plane, a 2D figure. That is a polygon. So the first set of polygons we want to talk about are triangles. So triangles have how many sides?
3.
Okay. So there is an equilateral triangle, and this, you can name a triangle two ways. You can name it with its sides and its angles. So an equilateral refers to the sides. So that means all sides are what? Equal. Okay, equivalent, equilateral. Another way, again, sides, to name it, is isosceles. And this is how I memorize an isosceles triangle. I saw two sides that were the same. So these two sides are the same, and this side might be a little bit different in the measure. So isosceles is I saw two sides that were the same. That's how I memorize it. And the last one is scalene. So scalene has all sides, and I can even change this a little bit, all sides that are different. So all measures of a scalene triangle have different measured sides, okay? So that is how we can name it with its sides. And now, with its angles, you can name it different ways. So triangles will have two names, their side name and their angle name. So their angle name, the first one is acute, okay? And acute refers to anything below 90 degrees. So if it has an 89-degree angle, then it's acute triangle, okay? So acute has to have all sides that are under 90 degrees, right?
Mm-hmm.
Right.
Okay. So under 90 degrees. Less than 90 degrees.
That's great.
Dang it. Less than 90 degrees. Yes, that's right. Okay. A right angle is one of my favorite kind of triangles.
Because it's always right.
It's always right. And it's marked with a special symbol sometimes.
Just like me.
So that is one angle that's 90 degrees is going to be a right angle. And the last one is obtuse. And that means one of the angles, and it only has to be one, is greater than 90 degrees. So it could be even 91 degrees. Now with angles, the thing that you have to remember, if I take any triangle, and maybe I'll show this in a different video. If I take any triangle, so for instance, this triangle here, and I cut off its points, okay? All of those, and I add them up, they're all going to equal 180 degrees, which is a straight line. So if I take them and I line them up, every single triangle ever in existence, no matter what, all the angles are going to add up to 180 degrees. So for instance, if this one had, I know this isn't 90, but I had a 90-degree angle here, and then a 30-degree angle here, and it said, okay, well, what's this angle right here? I know I can find that angle measure by adding these two up and then subtracting it from 180 to find that angle. And I'll let you try to find that out. So that's all about triangles. Now the next one is classifying all the other types of polygons that we have to classify in 5th grade. So I like to start at the top with a quadrilateral. I guess we're classifying, that's what it is, quadrilaterals. So if I look at a quadrilateral is any 4-sided shape. So this has 1, 2, 3, 4 sides. It's a quadrilateral. If I go down my tree, I split off into 2 segments. The first segment is a trapezoid. So a trapezoid is special because it has one set of parallel lines. And parallel lines are 2 lines that if I extend them clear out to space and they never end, they're never going to touch. So these 2 lines are the parallel sides, but these 2, if I extend them even more, they're eventually going to cross, okay? So that's not parallel. So they only have one set of parallel lines. Now the other is a parallelogram. So they have 2 sets of parallel lines. So these 2 lines are parallel, they'll never touch if I extend them out. And then these 2 sides are parallel, if I extend them, they'll never touch. So trapezoid is different than a parallelogram. Now, if I keep on going, unfortunately, trapezoid kind of lives by himself. Sorry, trapezoid. I think there's like another type of trapezoid, but that's it, okay? In parallelograms, now there's 2 types of parallelograms underneath that. With a rectangle, of course, it has 4 sides, like a quadrilateral. It has 2 sets of parallel lines. In addition to that, each of the corners are what?
90 degrees.
90 degrees, okay? Parallelograms don't have to have that. Rectangles do. On the other side, we have what's called a rhombus. Okay, they kind of looks like a diamond, and I did kind of a bad job on my rhombus. But a rhombus has 4 sides like a quadrilateral. It has 2 sets of parallel lines, but the sides are what? Equivalent. They don't have to have 90 degrees. They don't have 90 degrees, but each side is equal. At the very bottom, we have the most special figure of all, and I bet you guys know what that is. It's a what?
Square.
A square. A square combines all the elements of the figures above it. So it has 4 sides. It has all sides being parallel. These sides, all parallel. It has 4 90-degree angles, like a rectangle, and all sides are equal. Okay, so this is what I can say. A square is a rectangle. It's also a parallelogram. It's also a rhombus, and it's also a quadrilateral. So if I go up the tree, that's true. If I go down the tree, sometimes there are exceptions. For instance, are all parallelograms rectangles?
No.
No, because I have a square here, and that's also a parallelogram. Are all rhombuses parallelograms?
Yes.
Yes. So if I go up the tree, that's what I call it a tree. It's always true. If I go down the tree, sometimes it's false. Okay? So that was classifying plane figures. If you want to come in a little bit closer, Miss Hughes, so they can see our beautiful document and look at it. But if you have any questions, get onto Khan Academy, get onto YouTube, and you can look up the videos on that.